Welcome to another Code Breakdown. I'm Drew DuPont from Uptech Studio, and today I wanted to kick off a new screencast series, specifically about the state-based testing versus behavioral testing, because I feel like there's been quite a bit of confusion in the software development community lately about specifically the values of each of these types of testing and when it makes sense to use one versus the other. So instead of just doing like a presentation on this, I wanted to actually do an evaluation of the values by playing around with code. But before we get into that, I want to make sure that we're all on the same page in terms of what we're talking about when we talk about state-based testing. There's a lot of names for state-based testing that doesn't make it easy to talk about in the community, but generally it's referred to as state-based testing or classical testing or the Detroit style or Detroit school of testing. You'll hear people that do this type of testing referred to as classicists sometimes, and that's just because they're people that do classical testing. So what is classical testing or state-based testing? It's probably what you think of when you classically think of unit tests. You basically have the structure of doing some setup. Doing that setup is basically either setting up some inputs, or it could be setting the initial system state. Then you execute something, and then you assert the resulting state is what you expected it to be. So that could be the return value of a function, or it could be that the system is now in a different state and you're verifying that, or both. So down below, we have a little example here based on the example that we will be using in this series. And right now you can see we create this thing that's a mailer. It's actually a fake mailer in this case. We create this greeter, which is an actual greeter. We then create this salutations class that takes in a greeter and a mailer. We then, and this is all of our setup steps. And then we have this execute where we call salutations.arrival, and we hand it a name of Cindy, and that returns us this message. We then do our assertions where we expect that the message is equal to hello Cindy as the greeting, and we also verify state against the fake mailer by making sure that an email was sent. And so now we've recorded that an email was sent as 1 in the fake mailer, and that we also verified that the message sent in that email was hello Cindy. Okay, so here we are asserting the returned value as the state that was returned from here, and with this we are asserting the resulting state of part of the system. So this is what we think of and refer to as a classic or state-based test. The other type of test we're going to be talking about and exploring is this idea of behavioral testing. Behavioral testing also has many names. It's often referred to as Mockist testing, or the London style or London school of testing. It has a very similar structure. You do some setup. The setup that you do is different though. You instead mock out your collaborators, and then you execute something, and then you assert the collaborators were interacted with the way you expected them to be. So in this example below, we have this mock greeter that we create. It's got a hello method on it, and we mock that function out to return a value of something space some username. Okay. We also create a mock mailer that has a send method that by default in jest returns undefined. We then construct the salutations class the same way that we do in the previous example. We pass in the greeter, we pass in the mock mailer, and then we execute. When we execute, we ignore the return value in this case because we're not caring about asserting on that return value. And instead, what we're asserting on is the collaboration. And the way we do that is by using these special mock objects. So we have a mock greeter that has hello. And our expectation down here is saying that we expect that the mock greeter's hello method should be called with this user object that has the name of Hoopty. Okay? And so this is a Mockist test. We are evaluating and asserting the internal behavior of its collaborators and how salutations interacts with it. In this case, it's the interaction between the arrival method, its argument of Hoopty, and the mock greeter, right? And its hello method. So that's behavioral testing. To get a better understanding of this, let's actually look at the example that we will be driving most of our playing around with in terms of this. So we just looked at this one as the Mockist test, but you could generally what you do is when you're doing Mockist testing, you create a series of tests that verify each piece of the collaboration. So in this case, we tested the collaboration between the arrival method and the mock greeter hello. This test is similar. It's a Mockist test. We define our mock greeter and our mock mailer the same way. We construct our salutations class. We execute, and then our expectation is different this time though. In this one, we're expecting that our mock mailer's send method is called with this argument, which is the greeting message of something, some username. And so now we're testing that the return value of this greeter hello method is passed in to this mock mailer as an argument. And we can continue this. Here's another Mockist test. This one's a little bit different. This, we have the same thing. We have our greeter and our stub mailer, and we create our salutations class. We execute our arrival function. But here, we are actually doing an expectation on the return value of the arrival function. Now, what's interesting here is like doing an expectation like this feels very much like a state-based test or a classical test, because that's normally how we write expectations in those types of tests. However, we're doing that type of testing here for the purpose of verifying just another piece of the implementation and collaboration between the collaborators. Specifically, in this case, we are testing that the connection point between the result from the stub greeter and the message that's returned. And so we're verifying that the return value of this stub greeter is what is returned when we call arrival. And we're doing that with this expectation. So those are the Mockist tests. We can take a quick look at the classicist style tests, the classical state-based tests. These, we basically only have we have one needed, but we have 3 different variations of that test, just so you can see how you can use different tools to accomplish the same thing. So this first one, we have a test where we create a mailer. We're using jest spy functionality to create a spy mailer, and we are overriding the behavior of that send method to return undefined. So we're replacing the implementation of send and having it do nothing but return undefined. Then we create a greeter, we create our salutations class, and then we call arrival with Bob. And what we expect is that we get hello Bob, right? And if you're not familiar with a spy, you can think of a spy as just being able to record that, you know, a method was called on it. And then we, of course, test our state of the returned message to make sure that's correct. We have another state-based test down here. This one is using a classic fake. So the idea is in that is you create a fake mailer that abides by whatever the mailer interface is. And in this case, we create a simple array and we store, when send is called, instead of actually sending emails, we store the message in the messages array. And this enables us to create that fake mailer, create the greeter, pass it into salutations, run the arrival method with Cindy, verify that we get the correct message back, and then verify that the length of the mailer messages is what we expect it to be now, and verify that the value of the message is what we expect it to be now. And this, we can see we're verifying state, hence the state-based test. So we have a third example here, which is a different type, which is where we can use a mock to validate a effectful interaction, which is sometimes useful, not all the time useful in state-based tests, but sometimes useful specifically when we are interacting with an effectful collaborator, but not all the time when interacting with an effectful collaborator. We'll get into details on that a little bit later, but we create a mock mailer in this example. We create our greeter, we create the salutations, pass in the greeter and the mock mailer, and we call arrival, collect the message, and then we expect that our mock mailer send to have been called with the argument hello James. And then we expect the message to equal hello James, right? So these are all the tests that we have. We have a collection of state-based tests of these various different types, but they all basically do the same type of thing. And then we have these 3 Mockist tests up at the top. And the plan is to take these and this simple example, and we can look at the actual salutations implementation real quick. It's simply a class that takes in a greeter and a mailer, and then it has this arrival method that takes in a name and spits back a return string, which is the greeting. So we construct a user from the name. We then call greeting, the greeter hello, passing it the user. We get back a greeting. We then call the mailer send with whatever that greeting is, and then we return the greeting. It's a contrived example, but the thing is that we have multiple collaborators, which is interesting from the Mockist testing standpoint. And one of those collaborators happens to be an effectual one, specifically the mailer. And that is interesting both from a Mockist testing standpoint and a state-based testing standpoint. So I think it should be a decent enough example to go through all of these things. So let's remember what our goal is, right? Our goal is to gain an understanding of what the values are of each type of these tests, whether we're doing Mockist testing or behavioral testing, or if we're doing state-based testing. And that hopefully we can get a better idea of when it makes sense to use one type of testing versus the other. To do that, I think a good place to start is to understand why we write tests in the first place. And these are just a few reasons that I just came up with in my head and that I know of, but I'm sure there's more, and this is by no means exhaustive. But we have this idea of gaining confidence when refactoring, making sure that code's working, drive better design, provide documentation, make sure implementation doesn't change, and I'm sure there's more. And I'm not trying to make this an exhaustive list. And this series, and we're not going to cover all of these in this episode. We're only going to cover probably the first one, which is gain confidence with refactoring. But my plan is that we can continue to do more episodes that cover each of these specifically in relation to behavioral testing or state-based testing so that we can get a better understanding. And then at the end, we can bring all of the learnings together to hopefully help us decide when we should or should not be doing state-based testing or behavioral testing. So let's take a quick look at gaining confidence when refactoring. All right. To do that, I think the best place to do that, we have all these tests. Since we have all these tests, if we run the entire test suite, we can see that all 7 tests pass. That's great. So let's see. We want to make sure and understand, make sure we understand how these different types of tests relate to this idea of refactoring. To do that, we first need to understand what the concept of refactoring is. Refactoring is, by definition, the idea of changing the implementation inside of an abstraction or an interface and keeping the external behavior exactly the same. So the idea is that you're just changing the code internally, rewriting it in maybe a better fashion, but you're not changing the external behavior, okay? So I think a good way to go through that is probably to actually do a refactor. So let's look at our simple example. We have this salutations class again, and it's got this arrival function. Now, this arrivals method is constructing a user and then passing it to this greeter hello and then getting back the greeting. But we know from the tests and our examples that all that this greeting is returning is hello space whatever the username. So we could say like, hey, we could simplify this whole thing. We don't really need a whole greeting class to facilitate that. And we also don't need the concept of a user to facilitate that because we're just getting a name in here, an arrival. And we could instead just do const greeting equals hello plus name, and then pass the greeting to the mailer and then return the greeting. And it would be the same in terms of behavior, we think, but we'd be able to eliminate this greeting class and this user potentially. So if we go run our test suite, we can see we had 3 failures, okay? If we go to the top and we look at the failures, the first failure happens in Mockist behavioral, where we have collaborates with greeter's hello method. So that's this first one right here, this first test over here on the left. And we can see that it's failing because it's expecting it to have been called, but it was called 0 times. So we have this Mockist test, and it's saying, hey, mock greeter hello method was called 0 times, but we expected it to be called at least once with the user object of hoopty, but it wasn't called. And that's correct, because we just changed the code to get rid of that because we refactored it, right? But this is failing even though we refactored it. So is this giving us any sort of confidence that we refactored things correctly? I would argue that this test specifically is not. Okay, so let's look at the next failure. So the next failure is also in Mockist behavioral, and it collaborates with the mailer send method, right? So that's this test right here. And we can see this test is failing as well. And this one is failing, and it's failing because it expected to get something, some username as the argument here, but it's getting hello hoopty instead, okay? And that is because we removed the greeter out of the logic internally. So it's no longer interacting with the greeter to get this return value of something, some username. And now instead, it's just concatenating the hello and the username that was provided and using that as the greeting. And therefore, this is failing again. So again, is this giving us any confidence that our refactor was working correctly or not? I would say no. So let's look at the third one. The third one is a Mockist behavioral test failing again. And it's actually this one down here, which is our last Mockist test for this. And here we can see it's failing because it's getting something, some username. And when we're comparing the resulting message here, it's expecting it to be something, some username. But that's no longer true because our refactor changed it so that we're no longer using the greeter again, and instead we are creating the greeting message ourselves and returning that. So is this giving us any confidence in our refactor? Again, I would argue it's not. Let's keep going and looking at the rest of our tests, even though all of these are passing. So all of our state-based tests are passing. And we can see that because they are passing, the external behavior hasn't changed, right? So when we call arrival Bob, we're still, the mailer is still being called with hello Bob, and the message that we're returned is still hello Bob. So the external behavior is still exactly the same. Same goes for all the other three of these, right? We have same thing go on with Cindy. Arrival with Cindy. We get a message of hello Cindy. We see the message in the mailer, hello Cindy. Same thing with the state-based where we do mock of the effectful collaborator. We use James, and we see to have been called with James, and those match as well. So these tests, the state-based tests, do give us confidence that we've refactored properly, I believe, and the Mockist ones do not. Just to make sure that's true, let's actually go break the refactor. Let's say that oftentimes what people do is oftentimes people misuse the term refactor. It irritates me a bit, but people often use the term refactor when they are describing that they need to change the implementation of something to change the behavior. That's incorrect to some degree. Technically, it depends. Like, you have to understand what level of abstraction you're talking about when you're talking about doing a refactor. But let's assume that somebody is using the term incorrectly and they decide to change this to goodbye. Or even better, we'll go back with the greeter and we will change the greeter to use goodbye. Okay? And now if we go to our tests and run our test suite, we will see that 4 tests failed. And if we look, we have a classicist test that failed, the one with the spy. We see that this is failing because instead of hello Bob, which is what we expected as our greeting, we got goodbye Bob. So this is telling us that, hey, the change that was made is not consistent with the same external behavior. So that's giving us confidence that we didn't refactor properly. That's what we want. And then we have the same thing with the classical test with the classic fake, the same failure. Then we have this other classic test with the mock, and we see the same failure. Hello, James, but we got goodbye, James. And then we have this other state-based test that's inside the greeter specification, and it's failing for the same reason. So what's interesting about this is that all of our state-based tests failed correctly when we did not correctly refactor and we changed the external behavior. But what's interesting is that none of our Mockist tests or behavioral tests failed. They all completely quietly passed. So again, it seems like these Mockist or behavioral tests are providing no value in terms of this idea of gaining confidence of refactoring. And in fact, I would argue that they actually provide overhead. Because if we go back to our previous scenario, we go move the greeter back to hello real quick. And we run our test suite again to make sure everything's green. Cool, we're green. We go back to salutations. And let's do const greeting equals hello username again to do our refactor. When we do our refactor like this and we go back to our tests and run our suite, oh, hold on, I didn't do that right because I was letting Copilot drive. Silly me. No Copilot. Can't trust Copilot. Okay. Now we go back, we run our tests, and we have the 3 Mockist tests failing. Okay? So, we're back in this state. And why is this worse than just not giving us the confidence in our refactor? It's worse because this is now overhead. If we look at tests as a feedback mechanism, which is the primary goal of them, the whole idea of having value in a feedback mechanism is that when that feedback mechanism comes up and alerts you of something, that you have something practical to do, something pragmatic and useful to do based on it triggering or notifying you. In this case, we knew we just got rid of the use of greeter. We knew we just got rid of the use of the user object. However, all the notifications are telling us is that we just got rid of those things. That's not really very useful to me. I already know I intentionally got rid of those things, right? So all of this has to be trued up. To fix these behavioral tests, I would have to go through here and rework all of these behavioral tests, even though the external behavior stays the same and is correct. So I think this is actually worse than just not providing confidence. It's creating more work for me that is unnecessary. So that's gaining confidence to refactor in terms of state-based tests and behavioral tests. See you next time in the next code breakdown, where hopefully we'll learn some more about some more values of state-based tests and behavioral tests.